Hello, everyone. My name is Nathan Peck. I work as a developer advocate at AWS, and today I'm going to present a live stream today where I'm going to build a CI/CD pipeline from scratch, and hopefully we'll get to see the steps along the way. They go from taking your code, building a continuous integration process for merging it into your code version control, through to automatically building and deploying that application. And I'd love to take your questions at any point along the way. If you have something that doesn't make any sense, or you have some questions about something that's deeper pertaining to containers and the deployment pipeline, let me know, and I'll be happy to answer them. So let me start out first by bringing up this diagram that I constructed of the overall view of a CI/CD pipeline. And I created this to be sort of the 20,000 foot overview of the pieces of the pipeline, so we can see what we need to build in order to automatically build our application and deliver it to the cloud. And so you can see everything starts over there on the left with the developers. Obviously, the developers are going to be the ones that are going to be writing the code for your application. And they're going to be taking that code and merging into a version control system. And generally, people use GitHub, GitLab, something similar. Maybe they're also self-hosting their code. But from there, once the code is in version control, we have something called a test or deployment manager. And what that is doing is it's watching that version control system for new code that's been posted. And when new code is added, it's going to trigger an automatically managed process to take that code and do something with it. So in this case, particular to a containerized application, there's two things that need to happen whenever we merge code in. The first is we need to be able to build a Docker image based on our code. The second is that we need to be able to provision infrastructure on which to actually run that code. And then once the image is built and the infrastructure is provisioned, we're able to take that image and schedule it onto that infrastructure using a container scheduling process. And there's a couple different stacks that you can use. I want to show, first of all, a fully AWS stack for each of these steps in a CI/CD pipeline. So in this stack, for the code storage, the version control, we're using a service called AWS Code Commit. For the test and deployment, we're using Code Pipeline. We're using CloudFormation to provision the infrastructure, Code Build to build the image. We're storing the image in Elastic Container Registry, and we're scheduling it using Amazon Elastic Container Service. But there's more options. Like, I can also choose to go with a stack that uses a lot more open source components. For example, here we're storing the code in GitHub. We're using Jenkins to watch for the updates of that code in GitHub. We're doing the image build ourselves, probably inside of that Jenkins process. Maybe we're using Terraform from HashiCorp to provision the infrastructure, and we're scheduling that container out onto the infrastructure using Kubernetes. So today, what I've chosen to build for this stream is some of my favorite pieces. Some of them AWS, some of them not. In particular, what I've chosen to do is I've chosen to start from GitHub. So this is mostly an AWS stack. I will be using the GitHub. I'll be using Code Pipeline to watch for changes to the code. Builds happening in Code Build, and the containers are going to be stored and scheduled by Amazon Elastic Container Service. However, one change I'm going to make is I'm going to be using the Amazon AWS Cloud Development Kit to provision the infrastructure and actually orchestrate that code build of the Docker image and scheduling it with the ECS service. So I see one question in the chat before I go further into this explanation. Can you mix and match those open source tools with AWS native ones? And the answer is absolutely you can. So for example, in this case, this is a fairly limited mix because I am basically only using GitHub. The rest of the services are all AWS. But there's no reason why I couldn't have, for example, chosen to replace Amazon Elastic Container Service with a Kubernetes there. Or I could have chosen, instead of uploading my images to Amazon ECR. Instead, I'm going to use Docker Hub, for example. So basically, as long as you have these basic components inside of your CI/CD pipeline, you're going to be good. And it's just up to you to choose which service is best at each step along that pipeline. And for me personally, I do prefer to use a lot of the AWS ones because it provides a slightly deeper integration. There's some cool things related to this. I'll go into a little bit more detail as I go through the process of setting these up. But basically, I do generally prefer to use GitHub to store the code, just because I'm building a lot of open source stuff and stuff that I'm sharing, for example, on the Twitch stream. But the rest of the stuff, I like to use the AWS managed services. So let me kick things off by zooming in a little bit now on this diagram and starting out with that first part of CI/CD, which is the continuous integration. And let's talk a little bit about how to do continuous integration. Now, continuous integration is an interesting thing because if I was just starting out with, let's say, my code file here, and I was only going to run this application locally, and it was just me as a solo developer, I would actually end up with perfect continuous integration, because what I'd probably be doing is I would edit this code, I'd add some more statements to it, and then I'd rerun it locally. And every change that I made would be instantly integrated into the application. Where continuous integration starts to become a challenge is when you have multiple people on a team who are developing multiple features in parallel, and in particular when you're using source control. Because what will end up happening is each person will grab a copy of the code, for example, this file, and let's say one person starts adding a feature, let's say a new endpoint here. This is just a basic Node.js application that's an endpoint called awesome. And let's say somebody else starts adding an everything is awesome feature. Well, if they aren't careful, their code can end up being overwritten by someone else's code. And even if they do manage to resolve all their merge conflicts correctly, you can end up with a situation where the different pieces of code that are added end up interfering with each other, and constructing the final product that's going to be delivered to the public becomes convoluted. So I want to talk about one process that you can start out with first of all to make it easier for you to work with a team on your code and continuously integrate your changes that you're making with the changes that other developers are making on the team, and get all that code into one place where you can use that as a development or deployment target. So it starts out with a tool called Git, which I'm sure many of you developers are familiar with. But I want to talk about using Git branches to help you continually integrate your features. So here you can see, obviously, every Git repository comes for free with a master branch. And the master branch is intended to be, this is the state of the code that I want to be delivering to everyone. This is the intended current ready to go version of the code that I want to deliver maybe to the public. Should be bug free, should be tested. But you have the option to add extra branches to your repository. So here you can see, if I type git branch, it lists out the branches that I've added. And I have a few branches that I've added. There's a development branch, a master branch, and I also have two feature branches, one called My Awesome Feature and one called New Feature to Add. So I want to show how a lot of developers can use these branches to continuously integrate their code into the code base. So the first step to do is to create a branch. So I can create a branch. Let's make that everything is awesome feature. So I'll type git branch everything is awesome to create a branch. And if I type git branch, I can see I have a new everything is awesome branch, but I'm not currently on that branch. So I need to type checkout everything is awesome. And when I do that, I have a couple command line tools here to make it easier for me to work with the Git repository. And you can see that green section that used to be new feature to add on my command line prompt actually changed to everything is awesome. So that indicates that I am currently working on a code in the everything is awesome branch. And so what that allows me to do is, now if I switch back to my code editor, I can, once again, I can add a new endpoint to this code, and we'll call it everything is awesome. And we'll make it respond with like, wow. Okay, so now if I take that change and I add it to my Git repository, once again, a lot of you are probably already familiar with how to add stuff to a repository, but I just want to, just to be on the safe side, show how this works. So I can type git status, see that I have a change, git add, to add that change to my repository, and then commit to create, let's call it adding the everything is awesome feature. And so what this has done is now if I type git log, I have a new feature that's been added onto this branch called adding the everything is awesome feature. And if I take this branch and I say git push, it gives me a command to type to upload this feature branch that I've developed to GitHub, which is my chosen platform for hosting all this code. So let me show you how that ends up looking when I go over to the code editor. Inside of GitHub, it lists out the branches that are currently available. And you see that there is a master branch updated 26 minutes ago, a development branch updated 26 minutes ago. But then there's this new everything is awesome branch that was updated 43 seconds ago by Nathan Peck. And you see this little this dial right here that says one. There's one commit ahead of master. So that means that I've developed a feature and I've pushed it on this feature branch. And it is ready to be integrated into the code. Now, currently it's not integrated. If I go to the root of the repository, which is showing the master branch, and I look at my app, not this file, it's this index.js file in here, I'm not actually going to see my everything is awesome feature because it's not integrated yet. So what integration means is basically taking this potential code that is ready to be merged in and merging it in, and integration is the process by which you go about doing that. So GitHub makes it very easy to work with these different feature branches, and a lot of people use it in their workflow by just clicking this compare and pull request button. And what this does is it allows me as the author of this particular feature branch to open a pull request saying this adds a new feature that is super awesome. Now, ideally, if you were building a real feature on a real application, you would have a more verbose explanation of what your feature was. But you'll see when I create this pull request, what ends up happening is everybody else who is a maintainer or admin on the project is going to be able to see this pull request. They're going to be able to see that I want to add the feature, and they're going to be able to click on this Files Change tab and see that new code that I had added and see what the difference is. And one of the cool things that a lot of people like to do inside of a continuous integration process is add the idea of a reviewer. So oftentimes development teams, they have multiple developers who are all working on code. And developers are at different skill levels. Some developers might be just starting out. Some developers might be very experienced and capable of noticing issues in the code before they even become a problem. And so one of the things that can happen with continuous integration process is you have the option to review a change. And so, for example, as a reviewer, I can add a comment here that says, maybe this response is not interesting enough, right? And I can start a review. And what ends up happening is the author of the request can see that comment there and say, okay, well, maybe I should update this endpoint to make my response to the everything is awesome endpoint more interesting, right? Or, if everybody agrees, then it's time that everything is, if everybody agrees that it's time to approve this, then you can say, okay, it's time to merge this pull request. So once I merge the pull request, it's going to merge into a branch. And in this case, what I'm going to be doing is I'm going to be merging straight into the master branch. Because I'm doing a fairly simplified continuous integration process for this stream. but it can get fairly complex if you have multiple environments. For example, a lot of organizations, what they'll do is they'll end up having. I showed, for example, the master branch and the development branch. They'll have a multi-stage process where you take a particular feature and you merge it into development, and then from development you can merge development into master in order to take all those changes and that have been made, all those new features, and gather them together in the development branch, but then later merge that into the master branch to release to production, for example. And so here you can see that my everything is awesome feature is now shows up as merged. I can delete that branch that I had before. And now if I go to my code base and open that file, I can see that the everything is awesome feature has been added into that file. So hopefully this gives you an idea of how continuous integration works from the standpoint of actually working with the code and actually working with your GitHub repository. Now let's go to the next step, which is actually the deployment and delivery aspect of continuously integrating and delivering your code. So we have a process now for taking different features, putting them all together inside of one code base, inside of a master branch in a repository. The next step is to start automating the process for delivering that code to our end customers. And so in this case, what we're building a little API which responds with a couple different endpoints. There's a root endpoint, there's an awesome endpoint, and there's an everything is awesome endpoint. So it's nothing really complicated or fancy here, but this will serve as a placeholder that allows us to build out a pipeline and test to make sure that it works. So the tool that I've chosen to build out my pipeline and deliver my application is the Amazon AWS Cloud Development Kit. And I've gone into detail about this in a previous stream, but I do want to talk about the AWS CDK a little bit more in this stream and show what I built in order to help me deliver and build my application. And I see a question. Will this method handle blue-green swap in the containers? And the answer to that is yes. I will be showing that it's going to be blue-green swap in the containers inside of ECS. Right now, I'm still working through the initial steps of constructing that Docker container and pushing it. But then once I have that container automated by the pipeline on the AWS side, then I'll be able to show an actual blue-green swap happening. So let me start out first by showing the code that I'm going to be using to build the application and deliver it. So AWS CDK is an SDK that allows you to pull in different high-level resource types that you want to create on your AWS account. So in this case, ECS, EC2, and ELB, which is the Elastic Load Balancer. And define these resources using a language that you're familiar with, in this case, JavaScript. I wrote that core Node.js application with the Everything is Awesome endpoint using Node.js. So maybe I can actually write my infrastructure and define it using Node.js as well. So that's what I've done here. So you can see there's two stacks in this application. One is a base resources stack, which defines a network that I want to run everything inside of, and an ECS cluster. And then the next stack, I've created a Fargate task definition, an image definition, and a service, as well as an application load balancer to put in front of that service. And if you happen to have seen the stream a couple of weeks ago where I went through building an initial CDK app, you notice that this one is a little bit more complicated than the example I showed last time. The example I showed last time was designed to use the very highest level constructs available to show the simplicity of CDK. In this case, I zoomed down a little bit and created some of the lower level resources manually so that I had the most control over what was being created, and in order to speed up the CI/CD pipeline and make it faster. In particular, I use a trick that a lot of people aren't aware of with Amazon ECS and containers, which is that checking the health of your container can be optimized to make it much faster. And so here I've made my interval on the health check much faster, happening every 5 seconds. And I've made the thresholds lower as well. So it only takes 2 healthy or unhealthy checks to validate the health of the container. So with this structure defined, it allows me to use CDK to deploy my application. And the way that works is, let me switch back to my master branch again. I can run my deploy script, which is just executing a CDK. You can see the command there, CDK deploy. And you can see that what it does is it automatically builds and pushes my container. And the end output here is a DNS name, which if I load up in my browser, it has my message there, placeholder up and running. But currently what I've built in the master branch is not including that everything is awesome endpoint yet. If I try to fetch that, I'm just going to get cannot get everything is awesome. So let me build now a CI/CD pipeline to actually deliver this everything is awesome feature to my production environment. So I'm going to start out first by pulling in my code change to make sure I have it locally. And the solution that I'm going to be using for building this code pipeline is the AWS Code Pipeline Service. So let me start out by going to the console and services, and I'm going to select Code Pipeline. Oops. Looks like I got logged out here. I'll grab my keys real quick. I gotta use my Midway token to log into this. Whoops. Okay. All right. So I'm in my account now, and I'm gonna select Code Pipeline, and I'm gonna create a new pipeline. So creating a pipeline, I give it a name. I'm gonna call it Twitch CI/CD pipeline. And the pipeline requires a service role. So this is something you'll see time and time again with AWS services, that when you are using a service, a lot of times it requires a role. And what this role is going to do is it's going to give Code Pipeline permission to talk to all the different resources on my account. So I'm just going to allow AWS Code Pipeline to create the service role automatically. Just for simplicity, I don't want to have to create that manually and make sure that it has the right settings. And I'm going to also use the default settings here under the advanced settings. So what Code Pipeline gives me is it gives me a couple different stages that are part of the pipeline. You'll see over here on the steps, add source stage, add build stage, and add deploy stage. In particular, what we're going to be using today is the source stage and the build stage. So for source, I'm going to choose GitHub. I already pushed my code to GitHub, as I showed earlier. It's up here on GitHub. And I want to fetch it from GitHub in order to deliver it. So I'm going to hit the Connect to GitHub button. And because I'm already logged into GitHub, it's already able to pull in my list of repositories here. And I'm going to choose Nathan Peck, CI/CD. Where is it? Oops. CI/CD. Well, CDK. CDK-CI/CD. So that's the name of my repository that I have over here. You can see this name, CDK CI/CD. That's the repository that I'm going to be adding. And I want to choose which branch of that repository I'm going to be getting my source from in order to deliver it. I'm going to choose the master branch. And as you saw, those two different branches showed up, development and master. So as I said earlier, a lot of organizations will choose to have actually multiple pipelines to pull source from development, make sure that it works properly, maybe with a manual test, black box testing or whatever, and then develop and deploy the code from master after it's been merged in. But for this, and for ease of setup on the stream, I'm just going to be using one branch setup, which was just master. And I'm going to choose to detect changes using the GitHub webhooks. So this is the best for speed. it allows GitHub to notify code pipeline immediately whenever I push any code changes. And the code pipeline can respond to those code changes that it notices automatically. Unable to load branches. Whoops, what's going on here? Branches fail loading. Okay, well, I'll figure that out. Hopefully that works. Okay, so I'm going to choose a build stage now. I'm going to choose my build provider as AWS Code Build, as I mentioned earlier. So what Code Build is it's a tool which provides a environment for running some of your deployment scripts automatically whenever you need to respond to a code push that's happened. And in order to use Code Build, I have to create a project. So I'm going to click this Create Project button, and it'll take me from the code pipeline console into the Code Build pipeline, console. And I'll have to do another flow here to actually set this up. I see a question in the chat, is this Git repo public? Not yet. I will share this this repo after the stream. But right now I'm going to keep it private, just so that way I can mess around with it as I develop it, and then I'll open source it after it's ready. So let me create a project name for this, Twitch CI/CD, and I can add a description. I don't need to add that right now. The next step is to choose an environment. So environment image, I'm going to use a managed image that's already specified by Code Build. I could also use a custom image here if I wanted a very specific development environment, maybe a language that Code Build doesn't natively support, or some other binaries or system libraries in order to do my build. But the managed image, it works for me for almost everything that I can think of. I'm going to choose to start from Ubuntu, and I'm going to choose a standard runtime with the latest standard image from Code Build. I'm going to always use the latest image for this runtime version. And one thing I'm going to have to check here, and this is important if you want to do a Docker-based build, is you have to check this checkbox that says privileged. Enable this flag if you want to build Docker images or want your builds to get elevated privileges. And the reason for this is that Code Build uses Docker images. And in order for you to do a Docker build inside of a Docker image, you have to run Docker inside of Docker. And that requires a particular flag inside of Docker called privilege flag. And so I'm going to have to select that in order to enable the Docker builds inside of my Docker image. And I'm going to use once again, I'm going to let Code Build create its own role for this. And under build spec, this is the most important thing. This is where I actually define what's going to happen inside of the build. And I have two options. I can either insert build commands directly here in the editor, in the console, or I can use a build spec file. I really prefer to use a build spec file because I prefer to have my build defined as code inside the same repository alongside my actual application code. And once this is done, I'm going to hit continue to, I got to create a new name for this. Oops. Okay, I'm going to, actually I'll just use the existing one. Which one is it? Well, okay, I'll create a new role for this. Twitch CI/CD build role. Continue to code pipeline. Code build base policy. Whoops. Where's that one? Okay, so I got another role here somewhere. I need to find it. Additional configuration, is this the one? Let me go back. Try this again. These roles are tricky sometimes. Let me refresh this one again. Start over. I think I got a duplicate role here because I ran through this earlier today, and I think I left a role that was already on the pipeline. Okay, so I'll choose existing service role here, and I don't remember which one of these it was. I'll try this one here. And once again, I go to GitHub, connect to GitHub, Nathan Peck /CDK CICD and master branch. And I'm going to go to code build, create a project again. Okay. Twitch build. Managed image, Ubuntu with a standard runtime and latest version and privileged. Let's try this out. And yep, those all look good. Okay, so now it should be creating this, and oh, I see it. You lost privilege. Did I miss it? Whoops. Yep. Okay, I can fix that in a second, or after I create the pipeline itself. Good catch though. I would have run through that and had to do that one again. Okay, so in this case, I'm also going to skip the deploy stage here in this pipeline because I'm going to be using Cloud Development Kit to actually do the deploy itself. So skip deployment stage. Just give me a little warning, but that's okay. And I'm going to create pipeline. Okay, now before I go any further, I do need to fix my build project and add that privilege flag back like you caught. Zoom out here. One zoom back. Build details. Let me see if I remember where this is. Whoops. Keep zooming up too far. Edit. Environment. Yeah. Additional configuration. Where is it? See if I can find that privilege command again. Project configuration. Nope. Can I see what error you get, please? The warning I got earlier was about recommending that I use the code deploy service. I was saying Nathan doesn't use the AWS console very often. Yeah, you're right. I generally do prefer to use infrastructure as code to set this up. So a lot of times I do forget which section of the console a particular command is in. So I'm trying to find the section where I can specify that this needs to be a privileged build. Definitely have some issues on this. Okay, so it's not under source. Go back. Is it under environment? She looks like it would be here. Oh yeah, okay. So I had to. Okay, so here's where it is in case anybody else runs into the same issue. Once I create the environment, I have to click on the override button, and then I can click privileged again. So that was kind of hidden away behind there. This is something that happens sometimes. It hides away some of the complexity behind an extra button you have to click, but I got that now. Okay, so the question was about getting errors while running this for the first time today, thinking this might be it. Something about repo not existing or permissions. It could have had to do with linking your GitHub to code build so it can fetch the source. I did get an error earlier when I first created the pipeline. And I think it had to do because I recently did a switch and logged into my GitHub account. And so it may have still had a token from my previous GitHub account or something like that. So you do have to make sure that ideally you're already logged into GitHub and you've already authorized it with the right GitHub before you try to load in the project branches. But so at this point, what I do have set up is a code pipeline with a code build inside of it. Here's a Twitch CI/CD, and you can see that there are two stages to it: a source stage and a build stage. And you can see that this failed actually. Whoops. Okay, this does not have permissions to perform this action. Okay, so I need to fix my permissions on this to make sure that it has the right role. So let me go in here and edit stage, I'm going to edit this source stage. And let me see, where is it? I think I need to edit the overall settings for the entire pipeline to add the right. Let me see, is that right here? I need to find the where do I see the role that I have set up for this pipeline? Settings? No, that's not it. Well, I can find the roles over here in IAM. Okay. Roles. And let's type in code pipeline service. I think this is the one I used. I may have used a different one though. Let me double check and make sure. Check for each of these what permissions I have. This is like a one-click policy. Well, this isn't probably what you want to do for production, but I'm just going to attach an administrator policy on this to make sure that it has permissions to fetch the things that it needs to fetch and talk to the things that it needs to talk to. And so now if I go back here and go to my pipeline, Twitch CI/CD pipeline, and let's try again to release a change. And what we'll see happen ideally is it's going to be able to pull that source, but it's going to fail when it goes to the build because I haven't actually defined yet a command to run as part of that build inside the code build. And yeah, you see it succeeded this time. It was able to pull that code in, and you can see that the latest feature that I developed, that everything is awesome branch, was pulled in under source. I see a question, can you create a code pipeline with CDK? Yes. Technically, you can. I wanted to show the console interface for this. Obviously, I should have used CDK. CDK is definitely the thing I'm more familiar with using infrastructure as code. It seems like every time I go to the console, I end up making a misclick on something, but you know how it is sometimes. It all starts with, I wouldn't do this in production, but this will get it to work. Yeah, you caught me there. That's exactly right. I swear I created the right role earlier and it worked, but I must have just picked the wrong role again this time. So I wasn't sure which role I picked, so I added the administrator permission to it to make sure it would work for now. Okay, so I can see that the code build failed. The reason why is because I haven't actually specified a YAML file. You can see the error says YAML file does not exist. In order to fix that, I got to go back to my code editor, and I have to add a file in the root of my project. I'm going to call it buildspec.yml. And the format for this is fairly simple. I start with a version. 0.2 is the current version. And then I specify phases. And there can be one or more phases for a build. In this case, I want an install phase. I want a pre-build phase. I want a build phase. And I want a post-build phase. And so what I plan to do with these is install is going to be used for installing my dependencies for this application. Pre-build is going to be used for just making sure that my code is going to run properly. Build is going to be used for actually running the build and deploy, and then post-build is going to be used for tests. So under the install phase, I first need to specify what runtime version I'm going to be using for my application. In this case, I'm going to be using Node.js version 10. And I want to run some commands in there. The command I'm going to run is npm install. And so this first install is going to be installing the top level dependencies that are needed in order to do my build itself. You can see in this package.json file, I'm installing CDK itself, Mocha, which is a Node.js test framework, some request libraries that allow me to make requests to my API, and expect, which is a very nice library for creating expectations inside of your test. So it's going to be installing all of those dependencies. So under pre-build, pre-build is a great place to do setup for whatever you need to do in order for your build to run. And so in this case, I know that I need to run a command to bootstrap the CDK. And what this does is it sets up my AWS account so that way the Cloud Development Kit can actually run on my account. And the format for that is I need my account ID slash AWS region to tell CDK where I'm actually going to be running the bootstrap. Unfortunately, there's an environment variable for AWS region, but there's no environment variable for account ID. So I'm going to have to do something a little bit, it's going to look a little bit long, but what I'm going to do is I'm going to actually use the AWS CLI to fetch my account ID in here. So I'm going to say AWS STS, that stands for Simple Token Service, get caller identity, and I'm going to query the account field out of that. And so what this will do is that when it runs this command, it'll run this AWS CLI command inline to fetch my account ID and plug it in there. Oh, I forgot one more thing. I need to say output text. I have to put that in there. And that should construct the right command for bootstrapping my account. Okay. And then I'm going to run script synth to make sure that my CDK script will actually work properly. Now, under build, whoops, I forgot one thing here. I need to put this under commands. That would have caused a failure there. And then commands for build is actually pretty simple. I'm going to just do run script deploy. And post build, this is a great place, like I said earlier, for doing an integration test on whatever it is that you're running. So in this case, I want to set up an environment variable. I've set up my test that way that it takes the environment variable env URL and it sends a request to that to make sure that the service is up and responding, and it has an expect. So it says expect response to be placeholder up and running. So what I need to do is I need to figure out what that environment URL is. And inside of my infrastructure as code, I created an output here to output the external load balancer's DNS name under the key DNS. So what I can do here in my CI/CD build is I can once again call the AWS CLI inline to fetch that back out of the stack that I created. So AWS CloudFormation describes stacks, stack name, API, and specify my region. Yes, these two. And a lot of people don't know about this query query option on the AWS CLI. It's super useful because by default, a lot of the responses from the CLI have all the information about whatever the API response is. And it's too much. That's a good suggestion. You can use AWS region environment variable in there too, right? Yeah, that's what I'm going to do. AWS region query. So back to this query command. So the query is super useful because by default, it's going to be returning this big JSON document describing the stack. But I want just one piece of information out of that response, which is the particular DNS name of my load balancer. So you should definitely look up this this -- query command if you didn't know about this already, because it allows you to create these queries like this. It's kind of like the same format that jQuery or JQ command line tool uses, but it allows you to dig down deeper into that JSON, pull out a specific value from one of the keys inside of that JSON document. And once again, I want my output in text form. Okay, and then I want to run a npm test on that. So this is a very long one-liner here, but what it's doing is it's fetching my DNS name of my load balancer, and it's executing my tests, telling the tests what that load balancer URL is. I see. That's an interesting theme you got there. No word wrap. That's true, actually. Can I actually turn on word wrap here? Yeah, here we go. Toggle word wrap. Okay, there we go. That's much easier to read now. Good call on that. Okay. So this looks like it's got all the commands that I'm going to need in order to run my build. And once again, these are the same commands I would probably normally run locally on my machine if it was just me developing and deploying. But in this case, I want these to be automated. So I'm writing the script, which then code build can execute on the AWS side whenever I push my application. So let's see what happens. Hopefully this works. The first try. I'm going to add this file, adding a build spec to the project. And on git push. And let's see. Go back to Firefox and services, code pipeline, Twitch CI/CD. And there we see the code pipeline actually already picked up that push that I just made, adding a build spec to the project, and a code build is in progress. So I can click on that code build, and I can see the progress so far. And they added a great tail logs option here. So this window can just stay open here and tail the logs as they flow through. And you can see all those commands that I specified being run. I see a comment. I don't think we can use code build because we can't host code off premise. Yeah, that may actually be an issue for in some cases. Note that code build, yeah, it will pull in your code to use it, but it's not going to be keeping your code there off premise forever. It depends on what your limits are on how long you can have that code inside of an external provider. Like it could be in some cases that it's okay for you to use code deploy code build to pull in the code and do the build, as long as code build immediately discards that code. So definitely worth checking into. And so I can see that I got an error here. Obviously, you are not authorized to perform this operation. Once again, I did not get an IAM role correct. Okay, so I got to go back to my IAM role for this. And phase details. Which one was this one? Where's the... Well, I'll go into build projects again. See if I can find that IAM role that I used for this particular build. And I need to add... Oh, here we go. Here we go, right here. This one was easier to find. And so here you can see under IAM console, it starts out with just a base policy. But in order to do my deploy, I need a lot more different permissions like CloudFormation. I need ECS. Once again, I'm just going to add an administrator access on this. Ideally, you will, if you do this for production, you'll find a minimal policy, which has just the limited set of permissions that you need to actually do your build. In this case, I don't really have time to dig through and find the specific API calls that are being made. So I'm just going to say as a catch-all, I trust that code build isn't going to mess around with anything on my account that I don't want it to mess around with, because it's just running my own build script to do this particular deploy. I see a question, where is AWS region variable stored? So that particular variable is actually coming from code build itself. It's one of the built-in environment variables that comes for free inside of a code build when the code build runs. It's automatically setting that up. So let's go back to my build again and start tailing the logs. Okay, let's see if this works this time around. It should have all the permissions that it needs now in order to run that build. And so you see, once again, it did npm installed 520 packages, and yeah, good. We have a CDK deploy that's going off right now. And so this initial deploy is going to take a little bit of time because this is a fresh code build environment that's never run this particular build before. And I'm going to show you a trick that you can use to speed up the deploy and cache some things in between. So that way, if you make a change, it only has to deploy the things that are not actually changed since the last deploy. So I'll wait for this to make a little bit more progress before I launch into making that change and answer this question I see in the chat. would be nice to be able to pull our Bitbucket server, but I saw some people do a push instead. Not quite as nice, but I guess it works. Yeah, I don't remember if I saw if CodePipeline had integration with Bitbucket. It's a good question. Edit source. That would be cool if it did. Code commit ECR S3. Yeah, I don't see Bitbucket on here. So that would be a good suggestion to ask the team about. Like, they have a full feedback link here in the console where that feedback, in case you didn't know, if you send feedback on the console on a particular page, it'll go straight to that team. So you can say, I would like to see Bitbucket added to this. But one thing you could use as a stopgap solution is the Amazon S3 source, and have your own process for taking the code that happens in Bitbucket, zip it up and put that zip file inside of an Amazon S3 bucket, and then this source stage will be triggered based on that file being uploaded to the Amazon S3 bucket. So that will allow you to do like a sort of patch in the meantime, but then hopefully in the future, if we can add a direct Bitbucket integration here, that would be awesome. So let me cancel all this and go back to the code build again. Okay, yeah. And so you can see that what it did just now is it did a Docker build inside of a Docker image, so Docker inside Docker to build that image and push it, and you can see it's updating the service now. So one thing that'll happen right now is every time that I make a change anywhere in my repository, it'll have to rebuild that image from scratch. And that's not ideal. Ideally, I would have a cache to keep track of work that's already happened. Like if I rerun a Docker build locally on my local host, what'll happen is it'll be able to skip most of the steps because it's already done those locally, and it'll only have to update the things that had changed since the last time that it ran the build. So I can change that by going into my code build. Again, here's the Twitch build. And I'm going to go to artifacts, additional configuration, and there's a cache. And so if this is a little bit hidden, it took me a little bit of time to find this, but if you extend this additional configuration option, and then under cache type, you choose local cache, one of the options there is a Docker layer cache and a source cache. And so by enabling both of these, what it'll do is it'll keep track of Git metadata between subsequent builds, and it'll also be able to cache existing Docker layers that built in a previous build and reuse them for the next build. And once again, this also requires the privilege mode that we had to enable in order to do Docker builds in the first place. So I'll update this, and the Twitch build should be updated. Let me see if I can dismiss this message and go back to this and see. Okay, so this is currently still in progress. Let me go into the ECS console and show what's happening. So earlier, someone was asking about a blue-green deploy, and I want to show that it actually rotated through these tasks. And so what you'll see is I go into events, starting, here we go, 1551, I believe. Is this it? Yeah. So what it did was it started new tasks in parallel with the old tasks, and then it started draining connections from the older tasks in parallel with launching these new tasks. And so by default, the way I have my deploy set up is I have it set up with a minimum percentage of 50% and a maximum percentage of 200%. So what that allows ECS to do is actually launch a completely parallel set of my new container that has that awesome feature in it alongside my old container, and gradually switch the traffic over by shutting down one container and starting up a new container. Shutting down one container and setting up a new container. And that is the answer to that question. Is this because you updated the service definition with the new task definition? Absolutely, yeah. Just by updating the service definition with a new task definition, ECS will automatically do a gradual rollout across there. And you can control the percentages by saying, I want my minimum percentage to be 100%, my maximum percentage to be 200%. And so what that'll end up doing is it'll deploy a completely parallel set of the new task definition. That'll be the extra 100%, in addition to the baseline 100%, which is your older task definition. And they'll run in parallel with each other for a little while until the traffic is drained off and shifted over, and then the older ones get shut down. And so I find for a lot of people, that's all they really need for blue-green. Now, if you have an extremely high traffic service, you may require something a little bit more. Let's see what happened here. Oh, whoops. So it looks like my task failed because I messed up my expression here. Bad JMES path expression, unknown token equal. Okay, I know what I did. That's supposed to be equals. This happens. This is probably one of those infamous mistakes that I've made numerous times throughout my years as a developer, is accidentally putting a single equals instead of double equals. Okay, so let me fix that. And so this is one thing to keep in mind when you're doing a CI/CD pipeline. Every time you make a fix like this to your script, you do actually need to repush that. Fixing the JS path. Hit push. And so what this will do this time when it runs around is it should be able to find the URL of my environment, and then the test will pass because it'll be able to make a request to the endpoint because it has the URL for it. And hopefully we'll also be able to see that the first time I run that pipeline again, it'll be a little bit slower, but if I re-release it, it'll be almost instant because it'll have that Docker caching now. So you can see my change has already been picked up. This is one of the things I like the most about Code Pipeline is I don't have to do anything manual. It's literally just git push. And every time I git push, Pipeline picks that up, and then code build automatically starts executing in response. And you can see that they've done a lot of work to make it very fast. It used to take a few seconds before it would pick up the change, but now generally by the time that I do git push and I manage to make it into the AWS console and check, it's already pulled the source and it's already started my build. So it's running again. And you can see that this time around, it was a little bit faster on the base resources, no changes. I believe that the very first time I rerun this, it will be a bit slower on the API because it hasn't populated the cache yet. I just enabled the cache the last time right before I ran this build. But if I re-release it, it'll be able to use that cache and it'll be much faster this time around. So this will work. But in the meantime, what I can do is I can go back over to my iTurn. Let me see if I can find my environment URL from earlier. And I can verify that, what was it? / everything is awesome. Wow. Okay, so it worked. So this code pipeline delivered that new feature that I developed, that everything is awesome feature branch, and shipped it as a Docker container to Fargate, and now it's running there. And I see this everything is awesome response of wow. So once again, just to recap, looking back at this diagram so you can see what happened along the way. I, as a developer, built code in a feature branch, and by merging that code into the master branch of my GitHub repo, that triggered AWS Code Pipeline to pick up the process, and it kicked off a code build which used AWS Cloud Development Kit to build my container, push it to Amazon ECR, and then ask ECS to run that container across some infrastructure with Fargate. I see a wow in the chat. Yeah, yeah. It always amazes me the first time it works because this whole process used to be very hard to do. I remember when I first set up a CI/CD pipeline some years ago, and I had to use Jenkins. It was really a mission. It took like a little bit more than a week, almost maybe 2 weeks to get everything working right because we were running Jenkins on our own server that was sitting there on a machine in the corner in the office. and just getting the firewalls right to allow the Jenkins server to talk to everything you need to talk to, making sure that everything was protected. It wouldn't be able to be hacked. There were a lot of configuration issues with Jenkins. It's now so much easier with cloud services. And I do work for AWS, so a lot of times I will be recommending, like, for example, code build and code pipeline. But there are other great providers out there as well. One that I particularly like is Circle CI. I've used these before at a past startup, and Circle CI is a very, very good CI/CD provider that has a really great container integration. So I highly recommend checking them out as well if you're interested in building a CI/CD pipeline, because they integrate well with Kubernetes. I saw somebody earlier talk about Kubernetes, and they also integrate really well with ECS and a lot of other platforms as well to help you to build the container, push it to whatever registry you want, as well as push. And their interface is really slick as well. So definitely check it out. I see somebody saying I'm using Bamboo now. Bamboo is also pretty good, as well as Travis CI. So I am not. I tend to be partial to the AWS services because there's something very useful about having all your services on the same bill, having the same IAM permissions across everything that you are using. But as you saw earlier, sometimes IAM permissions can be a challenge. Maybe you just want to have a simple external build provider. In that case, Circle CI works. And as I said in this diagram, it doesn't really matter which providers you're using at each of these steps, as long as you have somebody there to fill that gap on the diagram and help you do that test manager or do that image build or do that infrastructure provisioning. There are a lot of different companies and services that will help you fill each of those gaps. So before I sign out, I want to give you a chance, if you have any extra questions you'd like to ask about CI/CD pipelines and containers. I see one. How difficult would it be to tie in Amplify for a front end to pair with the back end? I don't think it would be very difficult at all. Once again, once you have the CI/CD pipeline up, you can add new stuff to it pretty easily. And so, for example, it should be fairly easy for me to add Amplify code as a new stack inside of this infrastructure as code. So I have an API stack here. I could easily add a class for like front end. And inside of that front end class, I would be specifying my constructs for my Amplify front end. And the outputs of that previous stack, which was the DNS, I could easily take that output of the API URL and plug that into my Amplify build and deploy to tell the front end where it could find that backend API to talk to. So maybe I'll do another demo of that on a future stream, showing a front end as well as a back end. But yeah, it's hopefully this shows you the possibilities and gets you started thinking about how you can build your own CI/CD pipeline. And I'd love to hear about your successes or any problems you run into in the future. Feel free to hit me up on Twitter anytime with questions or to share. If you've done something awesome, written a tech blog. I'm always happy to share that out with people, especially if it's CI/CD and container related. I got one other question here. I'll answer before I go. Can you show integration with Fargate? Sorry, joined late. So it actually is using Fargate right now. So this app that I just built and deployed is using AWS Cloud Development Kit. And if I go to my app.js here, whoops, keep doing that. You'll see that I created a Fargate task definition and a Fargate service and an application load balancer. And so this is all I need actually to deploy onto Fargate, because all I have to do is change this from EC2 task definition to Fargate task definition. And it's that simple. So hopefully this will make it simple for all of you as well. And thanks a lot for joining and watching the stream today.